this video, I am going to explain one application of dot product in geometry. ABC is a triangle and D is the midpoint of BC. Then modulus of AB vector square plus modulus of AC vector square is equal to 2 times modulus of AD vector square plus modulus of BD vector square. So let us use dot product to prove this relation. Let A be the origin, then AB vector is B vector. AB vector is B vector. AC vector will be AC vector, let it be C vector. AB vector is B, AC vector is C. Since D is the midpoint, we can write the position vector of D, B vector plus C vector divided by 2. Because it's the midpoint, position vector of B is B, position vector of C is C. So add and divide by 2. Now first let us get a modulus of AD vector square. Modulus of AD vector square is same as AD vector square. And you know AD vector square is AD vector dot AD vector. By convention, AD vector dot AD vector square is AD vector square. Now AD vector is B vector plus C vector by 2, because the position vector of D is B vector plus C vector by 2. AD is the origin. So AD vector is B vector plus C vector by 2. This is AD vector. Position vector of D vector is AD vector. A is the origin. So AD vector. So instead of AD vector, we can write B vector plus C vector by 2. Dot again AD vector. So B vector plus C vector by 2. 2 into 2, 4. Then it can written as 1 by 4. Then B vector dot B vector. That is B vector square. So B vector square can be written as modulus of B square. Then C vector dot C vector, that is C vector square, that can be written as modulus of C square. Then B dot C, then again B dot C. Dot product is commutative, so C vector dot B vector can be written as B vector dot C vector. So 2 times B vector dot C vector. Next we have to get a modulus of BD square. We are proving from this side, left side, try to get the right side. Try to get the right side first, and we can show that it is equal to the left hand side. So now BD vector square, so BD. Modulus of BD vector square is same as BD square. Then vector square is same as dot product BD vector dot BD vector. Then we have to get a BD vector. We know the position vector of D and position vector of B. Position vector of D is B vector plus C vector by 2 minus position vector of B. Position vector of B is B vector. Now 2 into B vector is 2B vector. So B vector minus 2 times B vector is minus B vector. So it can be written as C minus B vector by C vector minus B vector by 2. So for this BD vector, we can write C vector minus B vector by 2, then dot again BD vector. So again C vector minus B vector by 2. So 2 into 2, 4. Now when you take the dot product, C vector dot C vector can be written as modulus of C square, C vector square. Then when you multiply these, take the dot product, minus into minus plus, so b vector dot b vector, so modulus of b vector square, then this minus b dot c, again minus b dot c, so 2 times b dot c. Now we have to add, now we got separately modulus of AD vector, then modulus of BD vector square. So add these two. So when you add these two, see 1 by 4 common, so write it outside. Then here modulus of b square, again here modulus of b square, so 2 times modulus of b square. Here modulus of c square, again modulus of c square, so 2 times modulus of c square. This term will get cancelled because here plus, here minus, so it will get cancelled. Now 2 common, so take it outside, then that 2 and this 4 will get cancelled. Here there will be a 2, take that 2 to this side, so then 2 taken outside, so here modulus of b square, b vector is AB vector because A is the origin. Then instead of modulus of B vector, you can write AB vector, so it's square, plus similarly modulus of C vector square, that is AC, modulus of AC vector square. So now we are getting this relation, modulus of AB vector square plus modulus of AC square is equal to 2 times modulus of AD square plus modulus of BD vector square. So thank you for watching.